I'm just wondering, what is the craziest thing that you've seen out there?
Their entire first floor ceiling was caved in and the entire house was covered in mold. It was just you couldn't stare at a wall that didn't have mold on it.
What would be your recommendation to get rid of the VOCs in a home?
Dilution is the solution to pollution. Now, dilution in Florida can be tricky because you have to bring in fresh air. But who the hell wants to bring in 95-degree, incredibly humid air directly into their house?
What does that mean somebody in a new construction house is living in? What type of environment are they living in?
The worst part about a new construction house are all the new chemicals.
Right.
So there's about 12,000 chemicals that go into a new building construction. And the fact that new construction is so tight, it's not going anywhere. It's off-gassing in there and it has nowhere to go.
For people who don't know you, this is Brantley May. He we've been doing jobs together for what, 3 years?
Yeah, something like that.
3 years. You just want to tell us a little bit like how you got into it. You look really young to have so much knowledge. Where does the passion come from, and what have you been working on?
Yeah. Well, I started as a mold remediator. My family was, doing mold remediation since I was 16. So I was the kid ripping it out. I wasn't getting paid for it, so I don't know if I really call it a job, but I was the guy ripping the mold out. And
like a Serve Pro type setup.
Yeah, exactly.
Okay.
Yeah, just doing mold remediation, demo work and cleaning and stuff. And I was always more interested in the investigation process. So I ended up starting my own company down the line and started doing mold inspections. And I kept coming across all these issues with, mold issues that nobody really knew the cause of. And I was like, man, what's causing these things? And that kind of had me dive into what I do now, which is more building science and building forensics. So my job these days is to, look at problems with a building or with mechanical systems and try to figure out what's causing the problem, the root cause of the issue. And we diagnose anything from mold issues, ventilation problems, chemical issues, and performance problems too. If you want a house more energy efficient or a building more energy efficient. So that's kind of what got me there. It started with mold.
Okay.
Yeah.
Just being the remediation company, you got a big water leak and you got a bunch of sheetrock damage. Your team was coming in, ripping out the wet stuff, drying it out, putting it back in.
Yeah.
And you did that for a certain amount of time.
Yeah, I did that with my family was the main people. I was off and on. You know
Okay.
how it is, like with a family business, you're kind of dabbling when you're young and stuff. And I actually stopped and started working for Apple for a little bit.
Okay.
I was a site support engineer for Apple. And I was doing root cause analysis for them, where I was diagnosing issues with, computers or phones. People didn't know what was going on. I would collect the data and diagnose them. And so it's funny, like when I came back like full force into the mold remediation, mold inspection stuff, I kind of took all those skills with me and brought them back in. And the actual investigation thing was interesting because not all the mold problems were a leak coming in. A lot of the mold problems were a lot more nuanced. Like there's humidity in here, or it's due to condensation, or maybe we open up a wall and we see mold, but contractors can't figure out what's going on or where the moisture came from. And so nowadays, that's what I do. I find out where the moisture is coming from and why it's humid and where the condensation is occurring and why. And then I redesign the building or I redesign the HVAC systems.
What's the craziest thing you've seen on stuff like this? Because people get sick, and I'm just wondering, what is the craziest thing that you've seen out there?
Well, the craziest thing I've seen mold-wise is when people just leave the house for a long period of time and something happens they don't realize. Matter of fact, I had one in Gainesville not too long ago where they had left for like 4 months or something for some sort of over the seas vacation, and their condensate line leaked, and it just kept leaking and kept leaking. There was no float switch.
Right.
And so when they came back home 4 months later, their entire first floor ceiling was caved in and the entire house was covered in mold. So it was like unbelievable for you to see this. It was just, you couldn't stare at a wall that didn't have mold on it.
You would think that if you're going to leave the house for 4 months, you'd have some type of monitoring device.
Oh yeah, I thought, at least a monitoring device, or maybe at least someone that's watching the house for you. You know what I mean? Like a house sitter.
Somebody come by and just Say
check on
hi.
it. Yeah, exactly. Yeah. So it was actually caught early. They weren't even back yet. It was caught early by the neighbors. The neighbors started noticing like a really bad smell. It was a mold smell. And so, yeah, they had someone go check on it, one of their contractors, and he walked in and he was like, I'm not even going fully in this house until we get someone to look at it. So it was nuts.
So you went in after the contractor and did some type of assessment, I'm assuming.
Yeah.
What were the next steps for them? I mean,
Got the place. It's like just dead.
so who pays for that when that happens?
Well, I don't know how that one ended, but they were definitely going for insurance. Now,
Okay.
whether or not the insurance claimed that it was negligible, I don't know. I mean, it's so funny how much could happen just because you didn't have a float switch. Because if there was an issue with the system overflowing, it would have just cut off. Now, they probably would have had mold anyway because the humidity would have increased in the house, but it wouldn't have been to that level.
Or it just makes it.
It just ate up the whole house. It
Yeah.
was nuts. Yeah.
When this whole mold thing started, when it was getting mainstream in like the late 90s, mid 90s, there was a house in Marsh Landing. I don't know if you're aware of it, but they tore the whole house down. It had to do with the fireplace coming up the side. They didn't have correct flashing. So when it rained, the water was coming in on this side of the wall. But everybody was just so extremely scared of mold in the home during this time frame. They just decided to bulldoze the whole home.
Yeah.
And I was involved in the project. I was in 95, 96, really young in the industry. But I just remember looking at this house and all of this good functional stuff in here. I was like, I just can't believe they're tearing the whole house down.
Yeah.
It was crazy.
It happens.
Yeah.
It's funny because sometimes that does need to happen, but it's very rare. Most of the time it's fixable. And so that's, again, it's kind of what we do is we come in and we try to investigate what's causing it. I mean, we do mold assessments and stuff too, where it's all the basic stuff like, oh, my water heater leaked, or, I'm finding mold around my supply vents. We come assess those things, but that's typically my other inspectors. When I get involved, it's mostly just trying to figure out what the heck's going on. They've already had 3 contractors out. They've already had 2 HVAC guys out, and nobody can really solve it. And so that's when we get involved.
When I think about people not being able to solve it, when you're looking at the home, people don't think about this, but when all the doors are shut, it's supposed to be sealed to a specific tightness. And, the Florida building code and mechanical code has, a certain amount of air changes in that house. But sometimes you'll find a house that's really, really leaky, or you're going to find a house that's really, really tight.
Right.
With all the investigative work that you do, would you rather have a really leaky house or a really tight house?
I'd rather have a really tight house.
Okay.
So that's a hot take because a lot of people are like, oh, houses are too tight these days. And it's true. Back in the day, we used to build buildings very differently. We had an energy crisis in the 70s and everything changed, right? Where there was an oil embargo and we couldn't figure out how to get gas prices down. And then the whole entire world freaked out and said, we need to cut energy as much as we can. And they tried to make houses more and more energy efficient. And it just like made the snowball effect where now everyone's focused on energy efficiency. It's a huge part of the code. But back in the day, we used to build buildings fairly leaky, and they used to be not very energy efficient. I mean, we didn't even used to put insulation in walls. And so nowadays, when you look at what's happening, right? Well, we used to build out of timber. Now we build out of particle board, right? We used to use real logs, and now we use, 2x4s that have been processed. And then we put insulation on the walls. So what happens is these walls become incredibly energy efficient. Back in the day when moisture used to get into these walls, it was what we call incidental water because it dried fairly easily because it wasn't very energy efficient. The wall wasn't. So if you think about how water has to dry, it needs energy, right? It has to have energy to make it evaporate. And so it used to evaporate just fine, dry out really fine. We used to have really dense wood in there, like lumber, like real lumber. And now we pack the wall full of insulation. And so if moisture gets in that wall and it's packed full of insulation and there's no energy transfer by design, what do you think is going to happen to the moisture? It's not going to go anywhere, right? It doesn't evaporate, so it just sits there. And instead of it being timber frame walls, now we're dealing with particle board, which has what's called a different hygric buffer capacity. It can hold a very different amount of moisture. Back in the day, we used to also, sail the seas with a wooden ship. Try doing that with particle board, see how far you get, right? So they just don't work the same. So now you have this wall system that has moisture in it. It doesn't dry because it's so energy efficient. And you have cheap materials that get moldy and rot really easily. And so to make matters worse, there is no air transfer either because we're trying to make these buildings tighter and tighter. And then on the inside of the house, all the meanwhile, you have people that are actually trying to live in it and occupy the space, and it's supposed to be healthy, but you're making it as tight as a sardine can. Where are these people getting their fresh air? Everything that they're doing in the house is stuck in the house, right? So the cooking and the cleaning and the showering, all that stuff is stuck inside, and they're not getting any ventilation. So you would look at this and say, well, I don't want a tight house. That sucks, right? But there's a way to do a tight house properly. You can make an energy efficient home. And the two biggest things that you got to do are keeping the outside out with good moisture barriers, right? So if you have all the good moisture controls on the outside of the building, you don't have to worry about the incidental water. And then for the inside, we have to do ventilation. That's the only way to go. If you're building really tight buildings, there has to be fresh air coming in through a ventilation system that's designed properly for your climate, and then it comes in your air conditioner and it gets distributed.
So I just want to pause you for a sec, because I think all the homes right now that are being built very tight.
Yeah.
And would you agree that most of the new construction homes you see, they're doing a pretty good job building them tight?
Whether they mean to or not, they're starting to build these things tight. Yeah.
So if we are in agreement that they're pretty much building them tight, and we're saying we need ventilation, how many of the homes are you seeing that have ventilation?
Very little.
So if very little of them are having ventilation, what does that mean somebody in a new construction house is living in? What type of environment are they living in?
The worst part about a new construction house are all the new chemicals.
Right.
So there's about 12,000 chemicals that go into a new building construction. And the fact that new construction is so tight, it's not going anywhere. It's off-gassing in there, and it has nowhere to go. And so it just gets stuck and it builds up. So the biggest problem...
Chemicals going into your skin.
Yeah, respiratory system, your eyes, and all that stuff.
And we're talking about like paint off-gassing, carpet off-gassing.
Yep, all the solvents.
And you're sleeping in it.
Yep, exactly. And then, a lot of times with people that just bought their brand new house, they want to bring all their new furniture in. They buy new couches, they buy new beds, they buy new whatever. Everything going in that house is just off-gassing, and the house is just, enclosed. Nobody opens their windows in Florida, not in the summer. And so, they're just baking with all these chemicals, and then everything else in the house gets stuck in there too.
So what are some of the solutions that somebody could do if they're building a new construction home, or if they already have a home that they've moved into, to be able to somehow neutralize these gases in the home? I'm having a hard time remembering the name of them.
Like VOCs?
VOCs, volatile organic compounds.
Yeah.
What would be your recommendation to get rid of the VOCs in a home?
Well, if it's a new construction home, you can't get rid of them because the number one rule is to remove the source, but you can't remove all your building materials that you just built with. So the second best thing to do is dilution. All right, dilution is the solution to pollution. Unless you can remove
I've never heard that one before. That's
it. So you got to do that. Now, dilution in Florida can be tricky because you have to bring in fresh air. But who the hell wants to bring in 95-degree, incredibly humid air directly into their house, right? It's gonna be an energy penalty for one, but it's also gonna be a moisture penalty. We already have a hard enough time removing moisture from our homes. It's very tricky to size air conditioners properly here. So we're either dealing with oversized systems or undersized systems. So how do you do it? The best way to do it in Florida is it has to go through a ventilating dehumidifier. So when that fresh air comes in from outside, before it ever hits the air conditioner or the house, it hits the dehumidifier. It gets filtered because these dehumidifiers, as you know, they have great filters in them. Then it gets dried, and then that filtered and dried air gets sent to the air conditioner, and then it can get filtered again and cooled. And then it gets sent to the house evenly. Yeah. So that's usually the best way to go. And the other unfortunate part is all of the houses that do have fresh air intakes on these new construction, one, they're only doing it because it's code and when you hit a certain air tightness. But two, they're not sending them through ventilating dehumidifiers. So you trade one issue, the ventilation issue, with another, which is the humidity. Yeah,
there's a whole subdivision in certain parts of Nocatee where they just have a fresh air duct and they're just pulling in 100% outside air.
Right.
And we go to their home and we're like, hey, we need to put a dehumidifier in and bring this outside air in. but right now, if you want to fix your problem, we need to shut this because this is the reason why we can't cool your house.
Yeah. Yeah. It's a cooling issue and a drying issue.
And, we attempt to explain to them, we are really wanting you to dilute what you have going on here. This is a new home. And then it's a balancing act. And some people make decisions, based off what they're able to afford, and not everybody can do it. But what ended up happening is that the builder just did it to meet code. And and I get it. They're under budgetary pressures too.
Yeah.
But I really feel like putting a DHU in to bring in the outside air is the way to be able to dilute the inside of the home, get the fresh air in. What do you think about like an ozone generating machine in that scenario to help out?
It's not going to do much.
It's not.
No, unfortunately. I mean, ozone is pretty good at breaking down chemicals. So we already know that. But you have to ask, what is it breaking it down into? It's most of the time breaking it down into other chemicals. So you're taking this really long, complex compound and you break it down into smaller ones, but those compounds are still there. And so without the dilution, you're just producing more chemicals. And so ozone generators, they have their place. They're very useful, especially in acute situations, like if you're trying to do restoration or something. But long term, they're not great for the house. The other thing too is, with ozone itself, it is technically a pollutant in and of itself because it's an oxidizer and it can cause like lung tissue and stuff, lung tissue scarring. But there are other machines that are ozone free that you can use, other PCO devices that are ozone free. But again, they are not going to fix the problem.
So what are some of the other devices that you're referring to that could be added that are ozone free?
You have like the Remy Halo, you have the air scrubber.
Okay.
All of those are other options for oxidizing the air.
Okay.
But they can still have that process of breaking down chemicals into other chemicals. So that's the downside we want to look at is, can they cause this problem? A house that has a lot of chemicals in the house, we probably don't want to do it. They're great for other reasons, ionizing the air and getting the dust out of the air, breaking down bacteria and viruses. They do great with that. But you have to identify, does this house have a huge chemical issue? And if it does, this probably isn't the best solution. The best solution is, hey, that $1,000 or whatever it is for the PCO device, let's use that towards fresh air intake.
Yeah, it's better to dilute.
Better dilute, yeah. Exactly.
Always better to dilute.
Yeah.
Can we take a look at the device you use to see what is in the home?
Yeah, but there's a lot.
So you go into a home and you want to figure out what's going on in the home. What do you do to start measuring to figure out what's in there? Like, what are you taking air samples?
Air sample. Probably the best device, like if you're just trying to do a screening tool, is something called an Instascope. Have you heard of that?
I have.
Okay.
Can you have that on your website? We can take a look at it.
It's not on my website, but you can just
pull it up,
search it up.
Instascope.
Yeah, Instascope. That's it right there.
Right there?
Yeah.
Okay.
There it is.
Okay. And what do you do with that thing?
That thing is sweet, man. Okay, so that device gives you a lot of real-time data.
Okay.
So it's going to give you the overall particulate in the air.
Okay.
A lot of these houses that are built really tight, one of the problems is they're built so tight and the air conditioners are so energy efficient, they don't run very often, right? Which for energy, that's what you want. You don't want your air conditioner to run all the time.
You want it to just cool it quick and shut off.
Yeah, that's it for energy, but that does a few things. One, we know it raises humidity because your air conditioner is also your dehumidifier, but also it raises the particulates. And people think, why would it raise the particulates? Well, think about it. Most homes, 99% of homes, their only filtration is their air conditioner. So if it's not running, you're not getting any filtration. And so especially in the wintertime, when it's part load season, it's 70 degrees outside of Florida, 70 degrees inside Florida, we always notice a trend, particulate levels increase. What are the particulates? Everything. It's the cooking emissions, it's the dogs and pet dander, it's the pollen that gets tracked in, it's all that stuff, it's all the dust. And so this machine, not only is it's going to give you particulate levels, so just an overall air quality generalization of how dirty is the air, so to speak.
How does that machine work? You walk around with it?
You walk around with it with a wand, and
okay.
It kind of gives you the overall particulate levels. But you know what else is really cool about this machine that nobody else does is it can actually identify what amount of those particulates are mold spores.
Okay.
Right there on site. So now it doesn't tell you what kind of mold, like it doesn't tell you that it's this species or that species, but it will give you a general sense and to say, whoa, why are the mold spores in here so much higher than outdoors or the other house I was at? It can also identify bacteria and viruses just from a real-time data sweep. You don't have to send it to a lab.
It's real time.
Real time, right there, boom.
Okay.
And I can track, the other thing is I don't have to charge the customer per room. I can just scan the whole house because I'm not, it's just a time thing, really not a lab fee.
So how long have you had that device?
So this device is brand new to me.
Okay.
Yeah, they're a little pricey. What's really
what's a little pricey?
40,000.
40,000.
40,000, yeah. Somewhere around there.
Pricey.
It's pretty pricey. But I looked at the math and I looked at how much money I was paying on lab fees and calibrating my other equipment and all this stuff, and my ROI on that was 1.5 years.
Really?
Mm-hmm. And
what was the other thing? It was like you set one in each room, and it was like a vacuum and
the
stuff.
spore trap sample.
Yeah. Okay.
Yeah, that's still in our toolbox. It's a great tool because that's going to tell us the type of mold. So This is the screening tool. You say, oh, maybe there's an issue in this room, this or that. You could take the spore trap sample and you can get an idea of like what type of mold is it, and that will help us identify: is it a water damage type of mold? Is it is it something that might be in the air conditioner? None of it trumps visual inspection, like looking around thoroughly. But screening tool wise, the other thing this does is carbon dioxide, which tells us how well ventilated the place is.
Yeah.
Because that's what we exhale. So if I go through a house and immediately get carbon dioxide levels, I know, okay, this place isn't ventilating right. I didn't have to do a blower door yet. I didn't have to do any of that. It also checks VOCs. So
that's an amazing tool.
It's an amazing tool. It does everything.
Yeah.
So everything that you need to kind of screen the house. I mean, honestly, every HVAC guy should have one of these because
we're gonna get one.
The V in ventilation, right?
Yes.
You got to know that. Chemical wise, air sampling wise, I mean, it's a huge valuable tool. And then you can kind of track down and identify issues. The reason I say HVAC guys would benefit from this most is because our job is investigation. So I'm there for hours looking around the house, opening up the sinks, looking under this, doing that, looking at the exterior. That's my job. But for an HVAC guy, you guys are there to look at the air conditioner, right? To fix an issue. But to screen the place really quick with that is kind of huge. Mm-hmm. So it's a great tool. There aren't many people that even do air quality testing. You guys are one of the only ones I know that even do any level of air quality testing as it is. So a lot of HVAC companies are behind you guys even with doing the air quality test. But I've never seen a single HVAC company with this thing.
Yeah, I that's the first time I've seen one. We have the spore trap that we can set in a room and it's basically a vacuum that's vacuuming, and and then we send it off and they tell us what's on there.
Yeah, that's a great tool.
I was on your website and I was seeing you were doing your own. You had your own microscope.
Yeah,
you were looking at it yourself.
Yeah.
And you were actually talking about one particular thing. Was it chromium?
Chromium.
Chromium.
Yeah.
Why were you so fixated on that? Because I've never heard of chromium. And if you go to his website, you can see the video I'm talking about. It was really impressive.
Yeah. It's a video on chromium?
Yeah.
It may have been on my Instagram.
Okay.
Yeah.
Can you tell me why you were so fixated on chromium?
Well, actually, exactly like you said, you've never heard of it, right?
I've never heard of it.
That's the thing. It's not very common. And so, but it's a huge water damage indicator. Okay. So if you see chromium needs a really high, what's called water activity level to grow. And so it would be like seeing a fish walking around your house. You'd be like, oh my God, there must be a lot of water here, right? And that's the thing. If you see chromium, that's an indicator that there's a huge water damage issue somewhere. Not a little condensation problem, not something growing in the vent. This is like a legit, flood or something caused this. And we saw a lot of it in that particular video. And I was like, oh my gosh, this is like the most I've seen all year, which tells me that the water damage event we already identified is really causing an air quality issue. And so the type of mold, the reason we like to look at it is because the type of mold tells you a lot. Every mold has a different ecological niche, different things that it likes to live on and grow on. And we've seen a lot of people make mistakes by taking these air samples and coming to the wrong conclusions. So for example, a really common mold that we see in water damage is something called Stachybotrys. Mm-hmm. Stachybotrys is the one that freaked everyone out in the 90s that got the ball rolling with the mold fear stuff. Well, Stachybotrys is very hydrophilic, meaning it likes a lot of water. It's also what's called cellulolytic, meaning it likes cellulose. Cellulose is trees and plants and things. And so I've seen a numerous amount of times someone taking an air sample, they see Stachybotrys in the air sample when they get their labs back. They saw some mold growing in the air conditioner and they say, it's in your air conditioner. And that's where the mold came from. Clean your air conditioner and you're right as rain. But the problem is Stachybotrys doesn't grow in air conditioners. It's cellulolytic, so it grows on dead plant.
It's not going to grow on a coil.
Couldn't grow on a coil.
Yes.
No way. And it's also too cold. And there's not enough moisture.
So if you're seeing it in other areas of the house, you got a water leak.
Exactly. Yeah. But if you don't know that, if you don't understand the mycology of it, then you're going to miss a lot of stuff. And the same is true in the inverse. I can look at an air conditioner and a lot of people say, can you tell what type of mold it is by what it looks like? Not usually, but I could narrow it down pretty good based on where it's growing, right? So if I told you I saw a polar bear, you would know I didn't see that walking around in Florida, right? It's the same thing. If I saw cladosporium in an elevated air sample, I say that could be in the air conditioner because it likes a colder environment. It typically likes to eat on things like dust. And so this is where we should check. So this is where the Instascope isn't so great because it's not telling you the type of mold, and where the stuff that you guys do with the spore trap sample is really useful.
Okay.
Yeah. But using them both together is the key.
Yeah.
Yeah.
So that's a really cool product. Some of the things like we see a lot of is really common. Somebody will leave the fan in the on position.
Oh yeah.
And all the grills in the home will start sweating. And then, we go to explain to them, how this happened. And then there's, sometimes there's some cleanup to do. We got to take the grills down, clean where the mold is growing on the grills. We see a lot of times people will, not change their air filters for long periods of time, which actually, depending on the filter, it might be something where it's actually catching more, but then it can cause harm to the air conditioning system. A lot of homes we go into, and I'm sure, he was just at one of our customers' homes and we had an oversized air conditioner. We're going to be working with the customer to fix that. But I'm sure when you walked into that room, you could just smell the humidity. And a lot of times when I walk into, a friend's home or, a customer's home or whoever, I can tell they have a humidity problem just by walking in. And Steve Kyler, who's our specialist in this area, he's like, the first thing you need to do is you need to get me to the house, meaning Steve, and I need to use my 5 senses.
Yeah.
And that's essentially what you're saying also, is that with your experience and everything you've been doing, you can walk in and you can have a pretty good idea of what tools you need to do next. To do that initial consultation, we've worked with people in the past where that initial consultation is like $10,000. We've worked with people where it's $5,000. I don't know how you like to work in that category. Do you just want to explain to people if they think they have a problem, like how you operate on that? Because the only reason why I'm bringing it up is I feel like a lot of people are scared to even have somebody come out because they're, you have some of these companies come out and they just try to sell you essentially a bunch of shit you don't need. And just if you could just explain that.
Well, whenever we get a call, like the humidity call is a big one here in Florida, right? Hey, we've been dealing with humidity and they want me to come out and investigate. Well, my job is to investigate when no one else could figure out why. And so the first thing I do, just for the benefit of the customer, is I say, well, have you went down the path of talking to your HVAC contractor? That's the first person I refer them to.
Really?
Yeah. I say, call your HVAC guy, make sure it's nothing stupid and simple, right? People have spent a lot of money for me to come out and I look, and then it turns out there was like a disconnected return duct in the attic or something. And it's like, well, here's all your humidity. And you spent a lot of money for me just to come out and do that when it could have been a couple $100 service call, So now I'm like, well, have you talked to your HVAC guy?
Okay.
Now keep in mind though, HVAC, I let the customers know there's 3 reasons why you'd have a humidity problem in a house. Either the building envelope isn't doing what it's supposed to. The building envelope is essentially what keeps the outside out. It's your walls, it's your ceiling.
The tent.
The tint of your house. Yeah, it's the environmental separator. Yeah. Exactly. If that's not performing properly, moisture will come in through, air, humidity, moisture goes from high to low.
So we got the house.
Yeah. So building envelope.
Right.
Mechanical systems.
air conditioning,
conditioning, ventilation, all that stuff. Yeah.
Mm-hmm.
And then occupant behavior.
Okay.
Those are the three issues that would cause humidity.
Okay.
So building envelope, mechanical systems, occupant behavior. A lot of times we find it's actually a mix of them. So maybe the building envelope has holes and penetrations it shouldn't, and then the mechanical system has a pressure imbalance drawing it in. And then the occupant likes it at 68 degrees, which causes a condensing surface. So we see this a lot, but to try to save them on money, we say, well, why don't you call the HVAC guy first and get the mechanical system thing out of the way? Make sure it's nothing stupid and obvious, right? And once you've exhausted that, call me back. Now, if they call us back and they said, Brantley, we've tried 3 or 4 different things, gather as much information as I can, try to get an understanding of what I need to do on site, and we build up a custom quote. That custom quote could look very different depending on where you are,
size of the home,
and the particular issue. But on a typical building forensics job from 2,000 to 5,000 square foot house, it's usually around 5 to 10,000 for everything that we have to do. But our job is to give you objective data, no guesswork, solve the problem, and redesign it. That's what we do.
Let's talk a little bit about the building envelope. Mm-hmm. I think we may have spoke about it a little bit. There is a way to test the building envelope. It's called a blower door. A lot of people will tell me, hey, everything was working fine and now it's not. And we go out and we check the air conditioning equipment. The air conditioning equipment's fine. Mm-hmm. Customer's still complaining, it's still not working right. And we find that something happened to the building envelope that the homeowner wasn't even aware of. Mm-hmm. And a lot of times we're running a wire in a spray foamed attic.
Yeah.
And a hole like this big in a spray foamed attic is a big hole. Mm-hmm. Because we're letting the moisture in and the moisture has no way of getting out.
Right.
And going in and pressurizing the home with the blower door is a really good way to find out what's going on. How often do you find yourself doing blower doors?
Well, on our building forensic stuff, if it's humidity related, it's almost every time.
Every time.
Oh yeah, you have to, because that's one of the 3 reasons, right?
Yeah.
So building envelope, and so we have to understand. And moisture doesn't come in because of poor insulation; it comes in because there's holes, and so we got to find the holes. And that's other than your eyeballs and understanding the building structure, that finding those holes, it can really only be done with the blower door test. And either pressurizing or depressurizing the house and looking for the holes.
Right.
Yeah.
And are you using infrared camera to help you find the holes?
That's part of it, infrared cameras. What we like to do is we like to kick the AC down while we're doing our other investigation to get the house nice and cold.
Okay.
And then when we turn that blower door on,
you're heating it right up.
It's really easy to see the hot air coming in because the temperature difference on the thermal imager. And then we use theatrical fog too.
Okay.
Where you can actually go around the perimeter, go in certain areas, and you can try to determine where this is coming in due to the fog. So that's a great tool. We use manometers, which measure pressure. Mm-hmm. So we can throw it in a room and measure the pressure of that room. The closer the pressure is in that room to the outdoors, we know it's so much connected to the outdoors. And so there's lots of tools we use to help determine and track down this air infiltration. But the biggest thing is just understanding the building. A lot of times when we put the blower door up, we already know where to look because we already suspect certain areas based on the investigation.
You're just using it to prove it.
Exactly, and that's what you need, right? And we don't want to be one of those guys, and this is a problem with a lot of HVAC guys, to be honest. They get a call, they come out, and they say, we need to add a dehumidifier, or we need to do this. Sometimes that is the case, but a lot of times it's not. Sometimes it's completely unrelated to their scope of work, and they're just trying to help. And what we try to do is we do not want to provide a solution without understanding the problem, right? And there's a lot of contractors that are guilty with that. No matter what field you're in, they try to provide a solution without fully understanding the problem. And so that's where we come in. And I can't go in there and say, I think it's that, or I'm guessing it's this, because then I'm right there in the same boat. So we have to do the blower door. We have to verify it. We have to get the data. And then once we come to an objective data where we've verified our hypothesis, we've proved it, okay, now we know exactly what to do. Because there's that 10% of the time that it confuses you, where you run the test or you do the thing and it's like, oh, that's not what's happening. I thought that's what it was.
Yeah.
And so you have to go down a different trail on the detective work.
Yeah, we had a big house where before we knew what we knew, where we were taking units out, putting new units in, installing a dehumidifier, and the problem was the attic was ventilated, and this was about a 8,000 square foot home on the ocean. Mm. And we don't ventilate attics anymore. You know, everybody is going spray foam route.
Right.
You can't bring all that attic ventilation. If you think about the home and you have a ventilated attic, and all of those penetrations in the sheetrock are holes into the attic, and it just makes it impossible to be able to control the building envelope.
Right.
There's still a lot of ventilated attics in Jacksonville. I've heard some downsides to using spray foam. You know, the spray foam's going to off gas. I haven't really looked at any hard data on that. Have you looked at anything on that?
Oh yeah, that's a big part of my job. Yeah.
So what is the spray foam doing to the home?
Well, there's two ways to look at it. It's the philosophical building science discussion. Should I have an enclosed attic or should I ventilate the attic? Which that has nothing to do with spray foam. You can use other products to seal an attic up. And then there's the should I use the chemical product spray foam? And so the chemical product spray foam is always going to have a risk of off-gassing. Depending on the type, they off-gas fire retardants and other things, but they may also not cure properly. It doesn't happen often, but you don't want to be that home where it doesn't cure properly. And so
so they're not getting a ratio of the A and the B, correct?
That's mostly what it is.
Okay.
Yeah. Now the ratios could be right, but then maybe the manufacturer put too much of something in. Or maybe the ratios are right and they put it on a roof deck that's way too hot or way too cold, or the attic was way too humid. I mean, it's chemistry. It's a chemical factory at the house. And so you have to know, the technicians know what they're doing. So that's tough. Now, as far as whether you go with a conventional, vented attic or an unvented attic, there's lots of pros and cons to both. And this is where you talk to your contractor and say, which one should I go with? Typically speaking, an unvented attic is usually more energy efficient. The one where it's an enclosed space, you're not allowing any outdoor air in. And here in Florida, we have all our ductwork in the attic. So all the ductwork is in a conditioned space. So it's less likely to sweat. If there's any leakage from the ductwork, which there always is, it's leaking into a conditioned space. So it's not energy loss. There's all these great things, but you have to do it right. And if you don't do an unvented attic right, you're going to cause lots of problems.
We did spray foam for about 6 years. We had the rig, we would spray foam. And it was so hard to keep that machine running because you're basically dealing with a part A and a part B, and then they're coming under pressure in a gun, and that gun is constantly getting clogged. You're constantly spraying, and it'll just spray A and not B, or sometimes it'll spray B and not A. And I have a lot of empathy for those guys doing that work, but I have seen it go wrong.
Yeah.
And it's something that if you're building a home and you get it spray foamed, you need to blower door test that home before you put the sheetrock up.
Yeah.
Because there can be a lot of stuff that gets messed.
100%.
I want to talk about zoning.
Okay.
Can we talk about zoning?
Yeah.
I hate zoning.
Okay.
If you don't know what zoning is where you have one air conditioning system with up to 6 or 7 thermostats, and you have dampers in your ductwork, and you have thermostats in each room. A lot of problems we've ran into. So I've designed a couple applications where I feel like it's working fairly well. What are your thoughts on zoning? What is some of the stuff you've seen?
Yeah, well, zoning's tricky. And the reason it's tricky is because what you're trying to do is you're trying to take one air conditioner that produces one temperature, and you're trying to put different temperatures in each room. It's like, well, how do you do that, right? A lot of people, homeowners, think that thermostat, when you set it to 72, that's 72 degree air coming out of your vent. That's not how it works. Your house would never cool. What actually works is your air conditioner is designed to get the air around about 20 degrees colder. So if you like your house at 75 degrees, the air goes into the return, and when it goes through the air conditioner, it gets pooped out around 55 degrees. So this 55 degree air coming out of the vent. Okay, so if there's one temperature, 55 degrees, coming out of your air conditioner, it's going to mix into the air, it's going to come out of the supply vent, mix, and then your thermostat actually has a little thermostat on it, and it tells you, a little thermometer says, okay, at 72, I'm satisfied, and shut down.
Yeah, the room temperature got to 72.
Yep, and I'm satisfied. So if it's producing one temperature, this air conditioner, how am I getting 3 or 4 different temperatures in the rooms? And like you said, it's those dampers. So when one room is satisfied, it closes it, right? It closes the duct and says, this room doesn't need anymore, and it continues to provide air to the other rooms. Now, what's the problem with that?
the pressure in the ductwork goes way up.
Exactly. Yeah, you're sending a certain amount of air through the ductwork, and you say, well, I'm going to close 66% of them. And then what do you think is going to happen to the pressure in the ductwork? You're still trying to blow the same amount of air, but you can't. So one, your duct loss goes up because any leaks you had in the ductwork are now more significant, and the air you lose more air in the attic. But secondly, when you have that pressure in the ductwork, the airflow slows down because it's working harder, right? So now the air is passing by that coil inside the air conditioner slower, and the air has more time to cool. So now maybe you don't have that 20-degree difference, making it 55 degrees. Maybe it's a 25-degree difference, almost a 30-degree difference. And now the air is going through your ductwork at like 45 degrees.
And everything starts sweating.
Right? And so you know how they try to fix that? It's something called a bypass damper.
Yeah.
So they say, well, we don't want all this pressure in the ductwork. Let's stick a duct in the supply side. So when that air gets cooled, some of it goes back, and then we'll connect it back to the return. So we'll supply some air right back to the returns. We'll release the pressure a little bit. But what's the problem with that? Well, that air that's going back to the return, what temperature is that?
Now it's super duper cold.
Yeah, it's 45-degree air, right?
Yeah.
And so now you're cooling it even further. And so now everything is sweating. And by the way, that bypass damper doesn't help much. It doesn't even fix the pressure problems that much.
Yeah.
And so lots of problems. The last thing that we see, which is missed a lot, is these zoned areas also have returns, right? But what's going to happen if you shut off all the supplies in that area, but you keep the returns?
You're going to keep pulling air out of that.
You're going to keep sucking air, and that means that room sucks because it's under negative pressure. And where's it going to pull that air from? It's going to pull it from the attic, the windows, the outlets, whatever, right? So you're causing all these crazy pressure imbalances. You're causing cooling issues. One room's going to be like ice cold. The other one's going to be hot. And it would be a lot better if you just had a unit per area, and if you can get away with it. I mean, max, you probably want 2 zones on a system, and it has to be the right type of system. The problem that we see is a lot of people try to do zone systems with a single stage, single fan speed unit. So if you have a single fan speed unit, it just has one speed of fan, 0 or 100%, whenever those ducts close and those dampers close, and there's only one zone calling, what happens is the fan doesn't know any different, and it just still runs at 100%.
Yeah.
But if you can get an air conditioner that can actually ramp down fan speed, it can kind of compensate for that pressure problem. But here's the other downside, not to make it more complicated. When you go down in fan speed, now what's happening is the same problem. The air is going by the coil too slow. So you still get the overcooling. So how do you fix it if you have a fan that can change speeds? The compressor outside also has to be able to change.
Yeah.
So instead of it doing 100% compression and making the refrigerant really cold, maybe it can do 66%. And those are called multi-stage systems.
Yeah.
Or maybe variable speed or inverter systems.
Yeah.
So now both of them work in tandem. Okay, so half the duct's closed, cool. I'm going to go half speed, and then the thingy outside is going to work half as hard. And those tend to work a lot better. Now you don't solve the pressure imbalances as much, because there's still airflow going in some areas and not in others, but you're going to solve a lot of the sweating and condensation. So if you're going to get, so basically summary, if you're going to get a zone system, it better be a multi-stage compressor and a variable speed air conditioner. That's the way to do it.
When we're talking about multi-stage equipment, there's a really good video that I did explaining the benefits of multi-stage equipment, because when you think about a typical Florida day, you wake up in the morning on a typical Florida day and it's 70 degrees outside at 95% humidity.
Right, yeah.
And then the day goes on and we get up, and we're talking about summertime. The day goes on, we get up into the 90s, and then the humidity is down into the 70s. It's almost a complete inverse. Yeah. So you wake up in the morning, it's sort of cool out, but the humidity is really high. Yeah. You get in the middle of the day, the temperature goes up, but the humidity doesn't come down that much. Maybe the humidity comes down to 70%. So if you're really going to design something for somebody's home, you would want a system that runs at different speeds and different capacities. So in the morning time, I would want that air conditioning system running on low speed with a long run time, removing a bunch of humidity.
Mm-hmm.
So in the morning, that air conditioning system is removing humidity. And then in the middle of the day, we crank that thing up, you know, into full gear, and it's really doing all of its sensible.
Yeah.
You know, we're taking on the heat of the day.
Yeah.
And it just really makes sense.
100%.
To have a variable speed indoor unit, a variable speed outdoor unit.
Yeah.
You're going to save on energy. Your home is going to have higher run times. You're going to have more particulate removal.
Mm-hmm.
You're going to have more humidity removal. You're just going to be much happier. Typically, the units are a lot quieter too because they're running on low speed and you can barely even hear them.
Yeah, and on the building envelope side, some areas of the home have more heat load than others. So, like if someone has a room with a lot of windows, they're getting a lot more heat gain than the others. If you don't have a system that's constantly running and the system just kicks on, cools the place, and kicks off, we don't know where the thermostat is. That room can start to heat up quicker. And now you're dealing with comfort issues. Mm-hmm. Whereas these variable speed, multi-stage compressor systems, if they're constantly running, constantly providing airflow, circulation, and cooling, then the whole house tends to be more evenly comfortable as well. That same concept you have, which is absolutely correct, dealing with the differences in the morning and the afternoon and night, it's the same concept over the season to season. Mm-hmm. And it's really hard. Man, Florida is tough to do a heat load calculation for and determine how much tonnage do you need. Do I need a 4-ton? Do I need a 5-ton? The reason it's so tough is because, you know, we want to size this thing to actually keep people comfortable during the summer. But the summer, like these, what we call peak loads, the highest temperature days, it's only maybe 2 months out of the year, 3 months out of the year, where we're trying to cool at maximum capacity. What happens when the rest of the year, like your autumn and your winter, which takes up a good chunk, and even spring, it's 75 degrees outside.
So you right back to your point earlier.
Yeah.
Your unit's not running.
Yeah.
And the particular count in your house goes way up.
Yeah.
And that's typically when people have their worst allergies.
Yeah.
A lot of people don't think about their air conditioning system as a vacuum, constantly vacuuming the air.
Yeah.
I mean, we should be treating it as an air purification device.
Mm-hmm.
Every air conditioner should have a 4-inch filter.
Oh, yeah.
Minimum. We should have a DHU with a filter on it, diluting, bringing in the outside air. We should have a non-ozone generating device to a degree, as long as they qualify for it. Mm-hmm. And then one of the products that I really like is a standalone bypass filtration system.
Oh, 100%. Yeah.
They are so nice. It's just constantly removing stuff.
Yeah, just a standalone air purifier is great too.
Yeah.
But you hit the nail on the head. I mean, your air conditioning system, if it has a 1-inch filter in it, that's not a air quality thing. That's a maintenance item.
Yeah, and people go to Home Depot and they buy this purple 3M filter that you can't get any air through.
Yeah, exactly.
And we stick it in and the unit freezes up and we're like, you know, this $40 1-inch filter you just bought, you need to take it back.
Exactly, yeah. Yeah, they're not great. So having the 4-inch, I recommend a lot, especially with my customers that have allergies and mold sensitivities. There's something called the Dust Free 16.
Okay.
And then IQ Air also makes another one. The Dust Free 16 is quite literally a HEPA filter for your system.
Okay.
It's almost the size of a dehumidifier with all these filters in it, and you just plug it in. And so all the air goes through this, and it's a crazy filtration system. You only have to replace it once a year. And so you're getting whole home filtration. But having that standalone system is great because those standalone air purifiers, the ones you just stick in a room, they're running 24/7. Your air conditioner's not, so you get that benefit. You're not going to get the same quality of filter in your air conditioner. I don't care how hard you try. If you can spend, you know, like there's a system called the Aspen Air. It's like $1,600. It's like crazy expensive, but this standalone system is amazing. I mean, it's got the pre-filter is about the same quality as regular air purifiers. And then you got a carbon filter, which is about 4 inches of like 5 pounds of carbon, which is really good at removing smells and chemicals. And then they have a micro HEPA filter, which is like medical grade. And to get that entire system for your air conditioner, it's like a $6,000, $7,000 system where you could just put it standalone and it's running 24/7. And so you get way more bang for buck too with standalone. The other benefit is, you know, most houses have about 20% to 30% duct loss. So if you have 1,000 CFM of air going through your ducts, two to 300 CFM of that is escaping into the attic, just because they're not that very airtight.
It's impossible to hermetically seal them.
You can't. Yeah, exactly. So what does that mean for your filtration? All that stuff that you're filtering, a lot of it's going out, right? And also your returns are pulling stuff in. So having something standalone means that you're not losing any efficiency on your filtration either.
Yeah, I really haven't thought about the benefit of a standalone filter that way.
Yeah.
But that makes a whole lot of sense, especially if you have somebody that's in a bedroom having a problem. Or if you know your air conditioning system isn't going to be running, having one of those running is a really good idea.
It really should be an accessory to your HVAC. That's the way I look at it. Because a lot of people ask me when they're trying to find the right air purifier, what size air purifier? This one says it only does 2,000 square feet. My house is 3,500. Ignore that. It doesn't matter, because wherever you put it, it's going to locally purify. But think about it. That clean air is getting sucked into your return, and then it's getting redistributed. It's going to secondarily clean the house. It's running 24/7. So I don't even look at size at that point. As long as it's one that's meant for a medium-sized home, you'll be fine. And so they have a lot of benefits in a lot of different ways, but I think they need to work in tandem. Your air conditioner should also have a good filter. Media filters are a must these days, because your media filter is also protecting your unit, it's protecting your ductwork, and it's filtering the air. So you're getting a lot of benefit from it regardless.
Can we just real briefly talk about where you had to go to get this knowledge? I mean, it's just so impressive to see somebody so young, so knowledgeable. I've worked with a lot of engineers in the area. Some of them are really, really good. I'm really impressed with you. And did you go to a particular school to do this? I'm sure you did.
Well, there's I'm kind of in a weird industry, because my niche is really dealing with mold issues and moisture issues. And so, I started in the mold industry doing the air quality stuff, and then I got more interested in the biology and science stuff. So I got multiple certifications as a microscopist to identify fungi and pollen and stuff. So that's where all my microscope stuff comes from. And then, in order to understand buildings better, I said, well, I need to become a building analyst. So I went through the Building Performance Institute to become a building analyst and a building envelope professional. That's how you learn how to do the blower door and energy audits and all that stuff. But simultaneously, I'm also doing my certifications for an indoor environmentalist. And that's where you learn about the ventilation and the chemicals and the bacteria and all that.
The indoor environmentalist is a big deal.
Oh, yeah.
That is a huge deal. I don't think there's very many people who have that certification.
There's not a lot, no. And I think Steve got his like a year or two ago, didn't he?
Yes.
Yeah, that's awesome. That's a hard certification to get.
Yeah. My brother Jimmy got it too. It's really tough.
Yeah, he might be due for his. I don't know how long, but so there's the CIE, which is the Council Certified Indoor Environmentalist. And that's pretty rigorous. But then there's the CIEC, and that's like the big dog. That one requires you to be an indoor environmentalist for 8 years. And you have to prove it with all these projects. It's really tough to get. I think it's just me and one other guy here in Northeast Florida that has that. And I remember when I tried to apply for it, I was like, well, I've been doing remediation since I was like 17. I applied for it and they said, nope, you can't do it yet. And I'm like, why not? I passed the test, right? I sent my application. They said, you just don't have enough diversity because most of your work was mold. And we want to see all this other stuff for 8 years. And I'm like, wow. So, and you know what the plot twist was? I was teaching the prep course for the class. Yeah, our training company actually had a prep, and they did decline me. I was like, what the heck? So they take the certification very seriously. So it's a great certification to have. Steve might be due for his soon. He should probably see if he can get that.
He should.
Yeah.
He really should. Well, this was fun. Thank you.
Yeah, of course.
Yeah. Do you want to let people know how to get in touch with you, or we can drop it in there? Or?
Yeah, I mean, if you want to go to my Instagram, it's brantley.iaq, which is indoor air quality, or just check out our website, envirohealth.co. If you're just trying to learn more, just follow me on Instagram. I post a lot of stuff HVAC related. If you need us for any reason, you can just go to our website.
Well, thank you.
Of course, man.
I really appreciate your time today. Thank you with all the help.
Thanks for having me.
Yeah.